Okay, we've reached the end of Unit 2, and so here's the Unit 2 review. I'm going to spend a couple of minutes talking about the unit as a whole and providing some strategies for studying. And then I will give you some problems to work on. These problems are meant to be sort of a more challenging variation of problems that we've done throughout the unit, and this should not be thought of as like the first thing that you look at. You should certainly complete all of the problems that we've done and practiced on throughout the unit, both in class and at home, before taking a look at these. Let's go ahead and get started. Okay, so the unit was about the derivative, and there's only one thing that you should start with, and that is the definition of the derivative. If that is not something that you fully understand, that makes sense to you conceptually, meaning you could sketch a graph and explain to someone what the definition of the derivative is, how it works, why it works, then you should not move on to anything else. You should start with that, go back and rework through those first couple of lessons and those problems, and make sure you understand the definition of the derivative. That for a function f of x, the derivative f prime of x is given by the limit as h approaches 0, f of x plus h minus f of x over h. Or if you like one of the other definitions, perhaps that's the one that comes to mind. But you're not doing anything until that is firmly planted in your mind. If you went into the test and all you knew was the definition of a derivative, but you knew it flawlessly, then you would do just fine. Obviously, you want to come in armored with a few more things, but this is by far the most important, and if you don't understand it fully, it'll make it really hard for you to grasp everything that comes after it, as well as any of the problems that just straight up ask you about the definition of a derivative and to apply it. So within our discussion of the derivative, we touched upon, I guess you could say, 5 main topics, and they're all interconnected, but I'll just go over them briefly. First thing we discussed is if you're given a graph of a function, using that to graph the derivative, the derivative function. And again, it's important. If you don't understand the definition of the derivative, that will make this very, very hard. But if you do, then you can take a look at the function f and analyze its slope at critical points and use that to create your graph of f prime. So the key thing here is to utilize your sign chart. Okay, then we moved on to tangent and normal lines and used the derivative to make that a little bit easier. The one thing that we emphasize a little more here is finding where the tangent is horizontal. So if you're trying to find a horizontal tangent, what you're doing is, you're setting f prime of x equal to 0 and finding the x value, solving for x to find the x value where the tangent is horizontal or the slope is 0. We moved on to differentiability, and differentiability is a key topic that will undoubtedly come up on the AP test, just like both of these will. And for differentiability, it's very important that you know the criteria. What does it mean for something to be differentiable? And then also the 4 examples of when something is non-differentiable and why it's non-differentiable. And then, of course, probably the biggest topic we covered with differentiability is the relationship between differentiability and continuity. So we learned that if a function is differentiable at a point, then it is also continuous at that point, but that it's possible for something to be continuous but not differentiable, looking at the absolute value function. And so understanding that theorem and being able to apply it in situations and make conclusions based off of it is going to be very important. Okay, so there that is. And then we moved on to the derivative rules. This was probably the most exciting lesson of the entire unit, maybe of the year so far, because it allowed us to move on from the limit definition at every turn, We don't have to use it now every time. But the derivative rules are a must. You must have them memorized absolutely down pat. There's really no excuse for not memorizing them, and you should know that if you know the basic idea of how you would prove them, that you can apply the limit definition in order to actually prove these derivative rules. It's unlikely that I'm going to ask you to prove the power rule on the test, but I might ask you some questions about it, and it certainly could come up, and it's something that is interesting and fundamental to math, which is the ability to prove something. And so there's a good chance, since I'm someone that really values proof, that I might put a question like that on the test. So derivative rules, make sure you can apply them, prove them, and above all, know them stone cold. And lastly, we discussed real-world application here. So there's not really a whole ton to say other than be able to know how you can apply the derivative in real-world situations, and in particular the couple that we looked at with taking the derivative of the position function to find the velocity function, and also with respect to the rate of change of geometric shapes and their area by taking the derivative of area functions and some other functions like volume functions. Then embedded within all of these topics are two things. The first is the different types of notation for the derivative, so prime notation, f prime of x, y prime, and then also Leibniz notation, which dy dx, df dx, the derivative of y with respect to x, so on and so forth. And just be mindful of all of those so that if they pop up in a question, you know it's being asked. And then what I think is probably the most important is that for each of these situations, you have a protocol, right? What is it that when I'm asked to do this, I go through and do, right? So, just to give you a very simple example, if you are given a graph of a function and you're asked to graph the derivative, what are the steps that you're going to take to make that happen? And you should, be able to say, for any of these situations, if you have a question, how would you attack it? And it all goes back to being able to understand the definition of the derivative. If you have that keen understanding and it makes sense to you intuitively, then you'll be able to figure your way out through any question that shows up on the test. So go back, go through, make sure you hit all those topics and come up with your protocols. Go through the questions that have been presented throughout each lesson and in class. Rework them separately. Give yourself little time tests. See how you're doing. Check your work. Email me with questions if you have them. And then move on to the review questions that I'll provide. Like I said, my aim is for them to be a little more challenging to make sure that you're really testing yourself in a way that will prepare you well for the exam.